What's up everyone? In this video, we look at how to perform process dumping and import reconstruction in Windows 10. In one of the previous videos, we performed unpacking and reconstruction of imports using LordPE on Windows 8.1. In Windows 10, LordPE is not working anymore, so we need to find an alternative. If you open it, notice that there are only system processes, and even with administrative privileges, the tool doesn't see user processes anymore. So we cannot dump processes this way. We need another solution. But first, let's pack a program and analyze it in IDA Pro. I will use PE View as a sample application and pack it. I'll use UPX. UPX-O flag specifies the output file. Let's check the result file and make sure it works as expected after packing. Right, it works and it can load other binaries. Great! The packed version works the same way as the original version. Open it in IDA. There is a warning that some imported modules will not be visible. That's fine, because we know the program is packed and some anomalies are expected. What we see here is actually the other layer of the application, which is the UPX packer. To reach the inner layer, meaning the initial application, we need to find a jump to the original entry point, also known as OEP. If you want to find out how to locate the OEP, check the previous video on UPX unpacking. This jump instruction over here takes us to the OEP. I'll set a breakpoint and then run the application. So I reached the jump to the entry point. I will take the jump using F7. There is a warning that the instruction pointer points to an address outside the sections initially defined as code. That's okay also. Why? Because actually that area was initially data and UPX decrypted it dynamically into our code. So here is the actual entry point to PE View, the original application, which is located in section UPX0. This detail will be useful later. To dump the file, I will use PD tool, process dump. I will post the link to the tool in the comments. For best results, run it as with administrator privileges. Go to the folder. Process dump will try by default to reconstruct the import table. We have to specify the PID of the process to dump and an output folder. Get the PID of the process using Process Explorer, this one over here, 6536. 6536 again. We will dump in this folder. Let's see what we have here. the dumped application doesn't actually work. First, let's check if the imports have been reconstructed using IDA Pro. You can see that the imports table doesn't have any entries. So let's dump it again, this time using the option to not reconstruct any imports. Then reconstruct them ourselves manually. We will add the parameter -ni to not reconstruct any imports. Alright, so now we'll reconstruct imports manually. The process is still running over here. We'll use Syla, which has two versions, x64 and x86. Our packed binary is actually 32 bytes. Notice here. So I will need to use the 32-bit version. Select the process over here, pview_packed. Notice that Syla already found a possible OEP. This is interesting. Let's copy and see what code is there. See here that this is actually the entry point of the main application, the outer UPX layer. It's not the OEP. The OEP is actually the code following the final jump out of the packing layer. So copy the correct OEP address from here. We now have the correct OEP. Let's use the option to automatically search for imports table. Check out the IAT auto search feature, then get the imports automatically, get imports. And finally, verify them. There are no invalid imports, so things look alright. Let's create a version of the dump with the correct imports. We need to select the dump file, this one over here, and Syla will create another binary with _sci appended to the name. That's the one, but unfortunately, if we try to run it, it still doesn't work. Let's figure out why. The reconstructed version is this one over here. Open it in a new IDA instance. Notice in the imports table that the imports appear to have been correctly reconstructed. Also notice that the entry point is also correct. The entry point is the same we've seen in the first IDA analysis. Same instructions, a call, test, jump, and another call. The code was dumped correctly. Notice that in this reconstructed version, the application starts from the correct entry point. But unfortunately, we've seen it doesn't work, so let's figure out why. I'll set up a breakpoint right on the entry point and run the application under debug. Okay, enter this function. Here are some calls to Windows APIs, and these calls are successful, meaning imports are correct. Notice here, we get results. Unfortunately, the execution fails afterwards because an instruction tries to reference an invalid memory address. What happened? This instruction tried to write the result of the API call from EAX into a memory address 0x408310. This block of code is exactly the same as in the initial version. Let's verify. Exactly the same. Let's have a look again. So we entered this call, then entered the second call, but in the initial application, the same code doesn't fail to write to that memory address. In IDA Pro, we can view the permissions for each of the memory segments by opening the segments view. What was the address which we couldn't write to? It was 408310. 408310 is located in this memory segment called UPX0. It is definitely in this range, but the segment doesn't have write permissions. Now go back to the packed version that works correctly and compare. Let's see the segments. Notice in this case that the UPX0, as expected, has indeed write permissions. So we're on to something here. Let's modify the reconstructed version and change the permissions of the segments. To do that, we'll use LordPE, which is still very useful. Go into PE editor and select the reconstructed version. Next, go to Sections and locate the section UPX0. Then edit the section header, which contains the flags. Make sure to select the writable option. Great! We still have the application open in IDA, so we need to close it. Then open the file again in LordPE editor. Go to Sections, then make UPX0 writable. Make sure to save the modified file. Final moment. Let's see. Awesome. The application now runs as expected. Nice. To recap, in this video, we have packed a Windows GUI application using UPX. We've traced the original entry point. We've dumped the process. We've reconstructed the imports and then fixed some memory permissions. And finally, we got a fully functional unpacked application version. This is the original file over here. Works, of course. Then we have the packed version here and the unpacked version. Both of them work exactly the same as the original. Thank you very much for watching, and if you found this useful, please share it so others can benefit as well. I'd love to have your opinion in the comments below, and don't forget to subscribe. Cheers!